All right. So on Friday, we kind of talked about type 1 and type 2 errors. We're just going to go into a little bit more depth with those today. All right. So I want to do it real quick. For a type 1 error, what that means is that we reject the null even though we shouldn't, or even though it's true. Bless you. And for type 2, we fail to conclude the alternative hypothesis, even though it's true. Everybody good? All right. So, you guys remember when we said Mr. Richards claims he's a 70% free throw shooter, and then we're going to say, hey, you're lying. You're overstating your ability. I believe it's less than 70%. Okay. So, if I asked you guys to describe a type 1 error, that would be, we reject the null hypothesis even though it's true. So you guys, if I rejected the null hypothesis, so I'm just going to cross this out, what are we going to conclude about Mr. Richards' shooting abilities? Go ahead.
He can shoot less than...
We're going to say to Mr. Richards... So hold on, I'm going to already redo this. We're going to conclude Richards is lying about his abilities. Even though he's not. What do you guys think so far? Everybody good? Guys, what's a possible consequence to this?
You challenge Mr. Richards to a game and he does a lot better than you think he will?
I'm going to just go with falsely accuse.
He doesn't get on a...
Because I don't want to play basketball, so I'm just going to falsely accuse him of lying.
I want to see that matchup.
He would win. I haven't played basketball in 25 years.
Are you, so there's been no time you've, shot a ball at a basket?
We did have one student faculty game for charity. That's it. And the staff asked if I would sit down most of the game.
Did you sit down most of the game?
Huh?
Did you sit down most of the game?
I do what I'm told. Yeah. I just want to be... everybody's got to know their role. Yeah.
Is that when Mr. Chafin was here?
Yeah.
Didn't he play basketball in France?
Mm-hmm.
That seems unfair.
Everybody else, we're all old, right? There's a lot of zone defense. That's all I'm saying. A lot of zone defense. All right, y'all. So what would a type 2 error look like?
Conclude he is right, but he's wrong.
Well, it's more that we're going to say we're going to fail to conclude he's lying. even though he isn't. Even though he is. And what's the consequence of that?
Someone for some reason thinks he's cool.
Richards is overconfident. Yeah.
Or he thinks on a basketball.
He gets beat really bad in basketball, gets put in his place.
I mean, I'd be okay with it. All right. So in the grand scheme of things, guys, does one of these seem more serious than the other?
The false accusation.
Yeah, in this case, I would say type 1 is more serious. Though,
Miss Meister.
yes.
But wouldn't type 2 be more serious because he's lying to you? So there's like a loss of trust in there.
I think the consequence of falsely accusing him of lying versus him thinking too highly of himself. I would much rather him think too highly of himself
I would not.
than falsely accuse somebody of lying. Myself.
Statistical Richards is scary.
Yeah, especially when you're a freshman in Algebra 1.
I mean, people tell me I'm scary.
How?
Yeah, but you're not egotistical.
Are you sure?
So you're saying she is scary.
I'm just saying, like, you're not me.
I mean, you know. I get told every year that I am scary.
You don't just randomly scream.
I feel like you could be stern, but only
No, it's not random when I scream.
I think you're very
I can be really, really cranky
I think
sometimes.
you are reasonable. You just don't want to get on your bad side.
Exactly. It's not random.
Can you go up a little bit?
All right. So you guys, let's think through. Is that we assume that the null hypothesis is true. So let's go ahead and describe what that distribution of all those possible p hats will look like if that null hypothesis is true. So let's start with the center. What's the center of all the p hats if in fact he is a 70% free throw shooter? 0.7. Will the shape be approximately normal?
Yes.
How do we figure that out? Not just because I drew it as normal, but we have to actually do some.
0.7 times 50, and then 0.3 times 50.
And when I do that, guys, I get 35 and 15, which are greater than 10, so we're good with that normal. What about the standard deviation of these p hats? We do 0.7 times 0.3 divided by 50, and then we take the square root of all of it. The mean is the 0.7, not the standard deviation. And I'm sure you guys will help me out with that because you're smarter than I am.
0.065.
0.06? Now, on this graph, we have all these different possible samples. Okay? And the whole idea with a type 2 error, or a type 1 error, or a type 2 error, is that our sample is one of like the crazier samples that makes us make the wrong conclusion. Is everybody good? If, now here's a huge if, huge if. Which hypothesis is true if I use this graph? The null or the alternative?
No.
The null, because we're assuming p is equal to 0.7. Is everybody with me? All right, so let's say I gather this sample. Do you think that one's going to be low enough that I'm going to reject that null hypothesis? Because it's pretty close, right? Or this one? Or this one? Keep in mind my alternative is a less than, so anything bigger is not going to make me conclude less than. You guys with me? What about this one? starting to get to the iffy side, right? Okay. Alright, so I'm gonna draw this like dividing line. I'm gonna call this area 0.05. Okay. And if we use that 0.05, are you guys with me that everything in this tail would make me reject the null hypothesis? Because like if I find that, let's say this is my p hat, if this area is 0.5, I'm definitely cool with saying this one's smaller than that 0.05. Do you guys see what I'm saying here? Okay. Wait a minute. So since the null hypothesis is true, this would be a type 1 error, yes? Is everybody good? So, are you guys with me that all the red p hats would make me reject that null hypothesis and make a type 1 error? Is everybody good? And what's the probability I do that? Okay. So, if alpha equals 0.05, my probability of a type 1 is 0.05. Thank you. Yep. Now, what if instead of using 0.05, I use 0.01 for that alpha, that level that helps us decide? All of a sudden my tail might look here, right? And if that's the case, what's the probability I make a type 1? How many p hats will I make a type 1 error for?
5.
So if that's the case, if I use 0.01, this p hat isn't going to make the wrong decision anymore. Because I wouldn't reject the null for 0.01 for this p hat. Is everybody with me? So, like, essentially it's only the p hats in this tail that would make me make a mistake, a type 1 error. Is everybody okay? So, if alpha equals 0.01, my probability of a type 1 is 1%. So here's the deal. The probability of a type 1 is always equal to that, what we call that significance level, that boundary that we use to decide, should I, how do I decide between rejecting and failing to reject? All right, so now, I want to go back up here really quick. Type 1 happens when we reject. Type 2 happens when we fail to reject. So here's the deal. Can we decrease the probability of rejecting and decrease the probability of failing to reject at the same time? They're opposite decisions. Do you guys get what I'm saying here? Okay, so if we reject, we could be making type 1. If we fail to reject, we could be making type 2. Why is this important? Well, if the probability of a type 1 error is alpha, okay, then if a type 1 is more serious, we want to lower the probability of a type 1, so we want to use a lower alpha. Like, for instance, 0.01. if a type 2 error is more serious, we'd want to decrease the probability of a type 2, so we're going to increase the probability of a type 1. Right? Because we can't, they work against each other, right? So as type 1 goes up, type 2 goes down, and vice versa. So we decide which one's more serious so we can minimize the one that's more serious. You guys with me? Okay, so then we're going to choose a higher alpha, but not like a big one. We might use 0.10 instead, because that's a typical value for alpha. And if neither is more serious, we typically use a middle value for alpha of 0.05. So in the real world, when someone's running one of these tests, what they're really trying to do is they start by saying which of these errors is more serious, and that tells them, do I want a high alpha? Do I want a low alpha? How do I decide how unlikely my sample needs to be? The answer is, well, it depends on which error is more serious and which error we're more willing to accept. If type 2 is more serious, we're more willing to accept a type 1 error, vice versa. Everybody good? All right.